So we have a circle and a sector that is 40 degrees, and this has a radius of 6. They want the distance from there to there. What's the distance of the entire circumference?
That would be...
What's the general formula for circumference?
Pi r squared.
That's area.
2 pi r.
So in this case, the full circumference is 12 pi. Now, whatever proportion that angle is of the full circle, that arc length is of the circumference. So I can figure out that arc length by figuring out what part of the circle I have. Well, what part of the circle do I have?
40 out of 360.
Correct. 40 over 360. I have that percentage of the circle. So that's going to give me that arc length. And if it was an area question, let's say they said, what's the area of the circle? I'm going to do it very similarly, which is to say I'm going to find the area is 36 pi of the whole circle, but this sector represents only 1/9 of the circle. So I'm going to multiply it by 40 over 360, which is the same as 1/9. And that would be the area of that sector. So whether they're asking about arc length or area of a sector, you're going to do the problem the same way. You're just going to find either the length of the circumference, multiply it by the percentage of our angle, and the same with area questions. So,
okay,
let's look at 12. It's still an arc length problem, so it's still a circumference problem. What's the full circumference?
360. Oh. 28. Oh, yeah, 28 pi.
Okay. And what part of the circumference are we looking at when we're talking about arc AB?
120 over 360.
Which is?
120 over 360, 1/3.
Correct. So I'm going to multiply that thing by 1/3. You actually, the correct way to do it is the way you said it. In other words, because it isn't always going to round down to a nice number. So it's always whatever that angle is over 360. That's the percentage that you have of that circumference. But just in this case, that happens to be 1/3. Okay? So your answer is 28 over 3 pi. That's the length of that arc, AB. Okay?
Yeah.
Should we do 13? You direct me. I mean, after we've done a couple of these, I think you're getting the idea, and we may not need to do them. We might want to be doing ones that you don't know how to do. Let me just take a quick look at 13.
All right.
The only difference in 13 and 12 is what?
It gives you a diameter instead.
Instead of a radius. So what's the radius in 13?
The radius is 4.
So what's the full circumference?
8 pi.
What part of the circumference are we dealing with?
45 degrees of it.
45 over 360. Always have to make that a ratio, because we're always going to be dealing with some part of the full circle. Never more than a whole. It's always part of the whole.
Okay.
So this number is always going to be less than 1. And then you just solve it. and whatever that solves to be. Actually, it looks like that's 360 over 360. Looks like that arc length is pi from A to B. All right. Doesn't look like you have any questions on sectors. Is that on maybe the second page, or?
I don't think so. We've just been working with problems like this recently.
Okay. Yeah, everything on this page appears to be arc length, which is related to circumference. In other words, they haven't asked for the area of a sector yet. But let's look at, you can take problems like this and word them many ways. And as we go deeper into this page, that's what's happening here. I'm trying to figure out the edge of this circle. You left a couple of points off there. I'm presuming they're saying that tell me if this is right or not, if you have the paper in front of you. That's 60 degrees. They're saying this angle here is the same as this angle here. That's what that says. QPR, there must be a Q down there. QPR is equal to RPS. So there's an S up here and a Q down there. And that's R and that's P. Okay, so they're saying they're equal. What is each of them? What is that angle? That angle. How do you find it out?
Subtract 60 from 360 and then divide it by 2.
So what do you get? That's pretty easy to do.
150.
Yeah. So each of these is 150. And now they want to know, find the indicated measure. So what is the measure of arc length QRS, which is from here to there? And they don't really want the length. This is not an arc length problem. This is a measurement of the arc problem. And the difference is that when you talk about arc length, your answer is in inches or feet. When you talk about the measure of an arc, your answer is in degrees. We have not been given a radius in this circle. So, oh yes we have, 8 feet. Okay, that's fine. Doesn't apply to this first question though. What's the measurement of QRS? I drew it wrong, hold on. QRS goes that way.
It's 300.
Correct. What is the measurement of, what is the length of QRS? Now we don't want our answer in degrees. In other words, the first answer was 300 degrees. That's 300 degrees. Our next answer is going to be in units. They didn't give us any units. Yes, they did, 8 feet. So our next answer is going to be in feet. So let's go back to these problems and do the problem exactly the way we did these problems. What's the full circumference? It's always where you start.
16 pi.
Okay, and what part of the circle are we looking at?
300 out of 360.
And that's all there is to it. And then you can reduce that to 5/6 if you want. And now it's 80 pi over 6. That's 40 pi over 3. That's fully simplified. 40 pi over 3 is the answer to 16. Okay, let's leave the circumference because we got some more questions that have to do with arc length. Let's answer all of those first. We're going to need the circumference to answer 19 also. What's the arc length of QR? 16 pi times what?
Wait, what?
What's the arc length of Q to R?
150.
No, that's the angle. That's the measurement of that arc. But that would be 150 degrees. When you're talking, once again, when we're talking arc length, you have to figure out the length of the circumference and then multiply it by the part of the circle that we're looking at.
Okay.
So the length of the circumference is still 16 pi as long as we're dealing with this circle. And what,
Okay.
from Q to R, what part of the circle is that?
That's, what do you mean?
What percentage of the circle is this part right here?
150 out of 360.
Always, whatever that central angle is, divided by 360 every time. And I'm not going to take this any further. We don't need to be spending our time on arithmetic. So we've done all three arc length questions, and we still need to do the measurement of the arc. What's the measurement of arc RSQ?
That would be 210 degrees.
Correct. What's the measurement of QR?
150 degrees.
Correct. So you see the difference between measurement of an arc and length of an arc. One is in degrees, the other is in feet. The length of an arc is, if I want the length of QR, and this was a piece of string, and I could cut it and straighten out the string, that's the length of QR. When they talk about the length of an arc, that's what they're talking about, is if I could turn it into a straight line, how long would it be? Whereas when they talk about the measurement of an arc, they're not talking about that at all. There's no straightening that out. The measurement of that arc is in degrees, and it has to do with the full circle being 360 degrees. All right, let's see.
Okay.
What else do we have here? What's the measure? Ooh, hold on. 21. Okay. 21, they're giving us the arc length, 8.73, and they've given us the radius, so can we come up with this angle? AQB.
Yes.
So let's do it. Where do we want to start? When you have a problem like this where you have to kind of go backwards, we can't start where we did up here. You still start with this.
Yeah.
Always. So what's the full circumference equal to?
100 pi.
20 pi. It's 2 pi r, not pi r squared.
Yeah.
Full circumference.
Okay.
Full circumference, I merely substitute 10 for r. Okay. And then I know, now let's work backwards a little bit. I know that if I take my full circumference and I multiply it by some fraction, I get 8.73, right? Well,
Yeah.
the unknown is the angle, which is always going to be divided by 360 to get that fraction. And I know that that's equal to 8.73. Now, I have one equation and only one variable. I can solve for x. And x is going to be this angle, AQB. So when they want the measurement of AB, it's the same as the measurement of its central angle. So whatever x comes out to be, stick a degree above it, and that's your answer for 21.
Okay.
You see how we did that? In other words,
Yeah.
I didn't know this angle. Every other problem, they've given us this central angle here. So I had to say, well, the central angle is x, and the percentage of the circle has to be x over 360. I can solve for x as long as I can write out the equation. 22, they're going to ask you to solve for the full circumference, which basically means we're going to have to figure out what, let's see, we got 4 minutes. We can do this problem. So, starting with that, don't have a radius, but I have an angle. So
Okay.
2 pi r is our circumference, even though I don't know what it is yet. What do I have to multiply that by in order to get 7.5?
Um, 3.25.
No. How do we get our ratio? Remember, we're always dealing with part of a circle. What part of a circle am I dealing with in number 22?
76 over 360.
That's it. Always. Whatever that angle is over 360. That's the part of the circle you're dealing with. Now notice, they're actually asking for the full circumference. So I could solve this 2 different ways. I could solve for r and then go back to this formula and figure out what the circumference is. But there's an easier way to solve this problem. Let's just solve for 2 pi r. Since that's the circumference, I can actually solve for 2 pi r relatively straightforward by multiplying it by the reciprocal of this. 360 over 76. I'm going to multiply the left side of the equation by that and the right side of the equation by that. When I multiply the right side of the equation, I'm left with 2 pi r. Well, that's another word for circumference. So the circumference is this number right here, whatever that comes out to be.
Okay.
And it's going to be in feet. I guess. They don't tell you what this 7.5 is, but everything has been in feet so far. So we couldn't really attach a unit to it. We just have to come up with a number, since they haven't given us units. All right, Mark, I got a 5 o'clock. I got to run. I will speak to you on Thursday.
All right, sounds good.
All right, bye-bye.